in English schools is I teach my students it's okay to get things wrong. It's fine to make an educated guess.
Yeah.
So I could do this. I could give you the numbers, and you can start putting a scale on it. But it's dead simple. Roughly, how it works is this. Fold it in half. Where that crease is will be the first planet. So the first planet, Neptune's there, Uranus would be there. Fold it in half towards the Sun, fold it in half again, and the crease where I'm folding it half again would be Saturn. Fold it in half again, and if you keep folding it in half, roughly, people are going to argue, going to look at the physics and look at the numbers and say, well, it's not quite, but it's not bad. Fold it in half again, and then you start getting quite difficult. But if you keep folding it in half, on each fold towards the Sun, they would be each planet, roughly. So that's a really neat, if you've got students, perhaps younger students, who look at those numbers and think, well, my students, younger students couldn't cope with millions, and you perhaps write them a standard form, perhaps would struggle with that. Well, just get them to fold it in half, and roughly, that's not a bad solar system. It's about right. It's quite a neat little, just dead simple, dead quick. Anyone can get this size paper. Just dead simple sort of activity. So then, I do this. So we've got an idea, all right? So let's build one. Let's build a solar system. So I give my students a football. Normal football. This is one activity we're not going to do because it takes too much time. But then I give them a big box of other stuff. I might give them all different size balls. Okay?
Yeah.
And I say to them, you pick what you think are the size of the planets. So I go back to that table, they've got some idea of the diameter, and they have to build a solar system. And this works really neat. If I give the Sun a football, then the Mercury will be the size of a pinhead.
Yeah.
So I'll get some. If you haven't got a pinhead, get the smallest ball you could find, and so on. A peppercorn, pinhead, and now a conker. Now that was a hard one. I don't think in Egypt it's called a conker. It's a horse chestnut fruit. You'll see the sizes. A cherry tomato, a raisin. And so I get them to pick these objects. Again, you can have this, so you don't need to jot them down. You can have this, and we can try and chat about what the sizes that is. So I've got them to pick, and so I've got my students. So one student's got a football, one student's got a pinhead, one student's got a peppercorn. And then I say to them, on this scale, will you stand where you think they should be? And as a class, we go out onto the field and we'll stand where we think it should be. And this gets really great. Mercury has to stand 6 metres away. Right? So I've got one student, so picture it. All right? And it's a great activity. Picture it. You've got a student with a football. What you always pick is your naughtiest lad. All right, the lad is always fidgeting and won't sit and listen. You give him the football because he's sitting there going, I'm the sun, I'm the sun. And then you've got somebody holding a pinhead, they're Mercury, 6 metres away. And now the students get a real feel for it. And then we get Venus. Who wants to be Venus? Right, Venus, you can stand there. And they get standing there. And so on. Now 15 metres, 23 metres. We can't do it in our classroom. Okay, let's go on to the corridor. And then it's brilliant. The principal or head teacher, the leader of the school, principal or head teacher comes along and they ask, what are you doing? And they say, oh, sorry, sir, I'm being the Earth, or I'm being Venus. And they say, oh, good lad, carry on, and stuff like that. 78 metres. Now we can't do it in our school corridor, so we have to go onto the field. and then you know, the kid, the child you don't like, you send 78 metres, go on, go over there, and 78 metres, and you can sort of pace it out. 142 metres. You can't do it now, too big. 450 metres away. And so then I asked them, well, where would you have to stand? And they say, oh, that's probably where my house is, or something like that. We try and work, maybe even get a map, try and work it out. Where would it be? So you built up the impossibility of building a model of the solar system. You can't, even on the size of a sun, as big as that, you can't build a solar system because it's so big. And then I ask, this is final thing, you'll have a go at activity in a moment. I ask then, okay, on that scale, 450 metres away, where's the next nearest star? And the students just don't get it. It'll be in London, or it'll be 100 kilometres away, it'll be stuff like that. Any ideas how many kilometres you think it away?
Outside the solar system?
It actually wouldn't be that far, but it would be about 6,700 kilometres away. So from here to, well, that's probably about about Africa, Egypt, isn't it? Yeah, it's about to Egypt. From here, on that scale, that's where the first star would be. And the students then, wow, it's so big. Okay? There's our little activity. These are nice clips. If you find them, I like to tell the students, that's to scale. So, there's the Earth, there's the Sun. We've just tried to do that. So our Sun is massive, isn't it? No.
Medium size.
It's quite a medium-sized star. Here's our star, compared to, but even then, compared to some of the real supergiants, our star is 1 pixel there. That's interesting. Betelgeuse. Betelgeuse has been, it's in the constellation of Orion, Betelgeuse has been behaving really strangely for quite a few years. We think that's the star that's going to supernova at some point. And then the students say, oh, is it going to supernova really soon? And I say, yeah, it's going to supernova dead soon. When? Oh, perhaps next 1,000,000 years or so. And because 1,000,000 years or so is actually really, really, really soon in terms of astronomical time. But of course it could well have supernovaed. It's about 500 and something light years away, so it could well have supernovaed. But when that supernovas, it's probably going to be bright as the sun in the day. We'll actually see it in the daylight. It's going to be fantastic. Okay.
Question, please.
Go on.
In the previous activity, we located the inner planets. How can we estimate the outer planets in this scale? When we float this,
Yes.
this
Yeah.
is the position of Mercury.
If you've folded them enough times, yeah. The problem becomes you have to fold it down and it gets too tight folding.
Yeah.
But if you can fold it enough times,
Yeah.
then that's about what it would be.
The
Yeah.
distance between Mars and Earth
Twice.
very far.
Yeah.
Twice.
Yeah.
Twice
Yeah.
the
Twice
distance.
the distance of Earth and Venus.
Yeah. That's why it's going to be quite difficult to get there. Yeah. Okay. Going to start talking about telescopes now, and a little practical activity. I'll love it if you've done this sort of thing, but a real common activity to teach our students about telescopes. We can actually build our own telescope. And the students just don't believe me. How can we build our own telescopes? So out of that and 2 lenses.
Yeah.
Okay? Is this a common activity?
We did here in science club.
Ah, okay. Just in case everyone's not seen it, you have 2 lenses. There is a fatter lens and a thinner lens.
Okay.
The fatter lens is called your eyepiece.
And the objective lens.
Sorry.
Okay, you need a help?
And your thinner lens is your objective. So the fatter lens goes this end.
Yeah.
You can see how I mount it with just some sticky blue tack. When you're doing this with your students, remind them that that's fixed, but it's not incredibly stable. I see so many students walk around with it like this, and I'm thinking, no, it's going to fall off, it's going to drop.
Yeah.
So just be careful. Your other lens, your objective, that should be the sum of the focal lengths away, so it should be about 60 centimetres. Some of them might perhaps need moving a bit closer, some of them perhaps need moving a little bit further away, but you can build it, and as you said, it's fascinating for the students. They just don't believe it. If you've not tried this, do have a go. That actually, with a bit of moving backwards and forwards, you do have to focus it.
Okay, it should, the distance is longitude, like longitude, long distance, that distance.
It should be long. No, it should be fixed at a certain distance. It should be about 60 centimetres. Because the focal length of this lens is 50, and the focal length is 10.
Okay.
The sum of the focal length should be about how far they are away.
Okay, so it depends on the focal length of the lens that I use.
Yeah, depending on what. I mean, clearly, if you've got different lenses, it's the sum of the focal lengths, and it's quite hard to use. The students think you're just going to stare through it and you'll sit, and you won't. Quite a lot of round the outside is blurred. You have to teach them. They have to sort of look through the centre of axes. Students get very look at it once. No, I can't see anything. It's rubbish. You do have to work it and move it backwards and forwards to try to get it. You start them off at round about 60, but then it takes a bit of fiddling backwards and forwards to have it, to get it to working. But there are 3 sets on each table. If you'd like to have a quick go, just set it up, have a go, do so. There's nothing much great to see here, much better to look out a window, but have a go and you should be able to see something.
Can we do this activity by using mirrors? This is a reflective.
That's right. I've not got, no, I've tried different experiments to get reflecting telescopes, but I've never really got anything very successful with it. I do want to show you one thing that I'm doing about telescopes. Yes, that's right. Yeah, that's the follow-up to this activity.
شايف النجمة من ورا
بس يعمل كده بس that's what we're doing. That's the refracting telescope. Then we're going to actually say, well, actually, the big we're not going to talk so much about that.
ما تاخد صورنا احنا
فكرني بأيام زمان.
We're going to work at some point. To put in there, they won't have to take the whole and actually see and understand what's happening. Just a couple of minutes, because lots of people have seen this and.
أنا شايف عينك قد كده.
بس جاي نهزر يعني على فكرة.
في certain targets
Last minute or so.
focal length of objective must be greater than the eye.
The focal length of the objective.
I see here that the focal length of objective lens is greater than that the eye.
The eyepiece, yes.
It should be like that.